Hi everyone, welcome to last episode of our Python programming series, episode 9. In this video, you will learn about Numpy, which is an essential library for data science and scientific computing. Without wasting time, let's get started. First, we will begin with knowing what exactly is Numpy. Numpy in short stands for Numerical Python, which is a powerful library specifically designed for numerical and scientific computing in Python. Its key features include multi-dimensional arrays or n-dimensional arrays that supports a variety of data types, making it efficient for handling large data sets. Additionally, NumPy is highly efficient and fast compared to pure Python list. And also, NumPy serves as a foundation for many other scientific and data manipulation libraries in Python, such as Pandas, Scientific Python, TensorFlow, and Matplotlib, facilitating seamless data analysis and visualization workflows. NumPy supports a wide range of linear algebra operations and mathematical functions that can be applied to arrays and matrices. To tell in simple words, the reason we use NumPy is because of its performance, simplicity, and a large active community. From data science and machine learning to scientific research, NumPy is used in variety of fields. Let's move on to its installing and importing. First, we will start with installing NumPy using pip, which is the package installer for Python. Before executing this command, make sure you have Python installed in your system. After that, open your command prompt or terminal and type this command pip install numpy. This command will download and install the latest version of numpy from the Python package index. Once the installation is complete, you are ready to import and start exploring its powerful features. To import numpy in your Python code, we can use import numpy as np. This statement imports the numpy library and assigns it in the alias np. Using an alias like np will make your code simpler. Instead of typing numpy every time, when you want to use a function from the library, you can simply use np. Now that we have seen how to install and import numpy, let's look at how to create numpy arrays. Arrays are the core components of NumPy. To create an array, we use np.array function. This is an example how we create an array using np.array function. By executing this code, creates a one-dimensional array which is straightforward and easy to understand. NumPy supports various types of arrays like one-dimensional array, two-dimensional array, multi-dimensional array. These arrays are highly efficient and form the backbone of NumPy functionalities. Next, let's see basic array operations. Arrays in NumPy comes with powerful operations. For example, array arithmetic and array slicing. These operations make data manipulation very easy. So let's explore these. First, array arithmetic. NumPy allows you to perform element-wise operations on arrays efficiently. Some common arithmetic operations you can perform on NumPy are addition, subtraction, multiplication, division, modulus, and power. Let's see how addition works. First, you need to import NumPy. After that, you need to create a couple of arrays to perform addition. Here we have two one-dimensional arrays, array 1 and array 2. As I have already said, NumPy allows you to add these arrays element-wise very easily. As you can see, the corresponding elements of the array are added together. The result is a new array where each element is the sum of the elements at the same position in the original array. Next, let's see how array slicing works. Array slicing in NumPy is a way to access a subset of elements from an array. It is a powerful feature that allows you to extract specific parts of an array without modifying the original array. Let's see in this example how it is done. For the first step, we import numpy as np, and in the second step, we create an array using np.array. You can slice arrays using the colon operator. The general syntax for slicing is array in brackets, start index and stop index, in between colon operator is present. If you run this code, As we know, the index starts from 0. Here we are performing slice operation in between start index 1, that is here, and 3. As we already know, 3 is excluded from the stop. So the output will print 20 and 30, which is part of this original array. And slicing will not create new arrays. Before we go any further in the video, if you are new to this channel, our channel is offering a free Python course to help you master programming. Your support means a lot to us. Please consider subscribing and hitting the like button. Also, make sure to share our videos in your college groups and with your friends. Let's make learning Python accessible to all. Coming to the video, let's talk about array attributes. Every NumPy array has attributes that provide crucial information. For example, shape gives the dimension of the array, size tells us the total number of elements, and dtype reveals the data type stored in the array. For example, if we print array.shape, it will show the dimensions of our array. Likewise, if we print size and dtype, it will show us the size and data type stored in the array. These attributes help us understand the structure and properties of our NumPy array, making it easier to work with them efficiently. Moving on, let's learn about mathematical operations. NumPy provides a wide range of mathematical operations. These operations can be performed on an array of any dimension, making NumPy a fundamental tool for numerical computing in Python. NumPy simplifies both basic and advanced mathematical operations. For example, basic mathematical operations use functions like sum function, mean function, max function, or min function to find sum, mean, maximum, and minimum of an array. Advanced mathematical operations involve performing square root with np dot square of array or exponential function with np dot exponential of array. Next up, let's explore random number generation capabilities. Generating random numbers is another amazing feature of NumPy. For example, to generate random floats, you can use this. By executing this code, you will get a 2 by 3 array, meaning 2 rows and 3 columns filled with random float numbers. These float numbers are uniformly distributed in the range 0.0 to 1.0, and the shape of the array is determined by the tuple 2, 3. And to generate random integers, we use np.random.randint. By executing this code, generates a 3 by 3 array, meaning 3 rows and 3 columns filled with random integers. These integers are uniformly distributed in the range between 0 and 10. And the size parameter specifies the shape of the output array, which in this case 3, 3. These random number generation functions are useful for a variety of applications such as statistical analysis, testing, and simulations. Finally, let's discuss some real-world use cases. NumPy applications are vast and is essential for various fields. In machine learning, it pre-processes the data for analysis. In statistical analysis and data visualization, it calculates key statistics and integrates with visualization tools like Matplotlib. In physics and engineering, it aids in numerical simulations and solving complex problems. NumPy's versatility and performance make it crucial for scientific and analytical computing. To summarize, NumPy is a game changer for anyone working with data science, machine learning, or scientific computing. This is the end for our Python programming series. Hope you learned a lot. Don't forget to like, share, and subscribe.